Good afternoon and welcome to NASA headquarters. My name is Ashley Edwards and it's my pleasure to introduce Doug Cooke, Associate Administrator for the Exploration Systems Mission Directorate, and his deputy, Dr. Lori Leshin. Today, Doug and Lori are going to give you a status on the ongoing activities of the Directorate, and then they're going to give you some insight into the planning for the proposed President's budget. Finally, we'll do some questions from headquarters and then from around the centers. So with that, I'd like to turn it over to Doug and Lori. Start with you, Doug.
Thank you, Ashley. Thank you all for joining us here this afternoon. Before I get into the heart of the discussion, I do want to introduce Lori. I think many of you have met Lori, but she's been here now since about the first of the calendar year, and already I've found that I rely on her incredibly at this point. We come from different backgrounds, mine from engineering and hers more from the science end of things, and I think we're complementary in our abilities, and she brings really great skills to our office. Really has contributed a lot so far. So she'll talk more about her background as I turn it over to her a little bit later. And but I really appreciate Lori coming to work with us. The purpose for this session this afternoon is to communicate. We're living in times that are uncertain and where there's change, and it's important that we communicate. We want to do it through this type of forum as well as others, and toward the end of this, Ashley will talk about a new website that we'll be putting online to communicate with as well. So what we want to do is to let you know what we are learning, what we are working through, the planning that we're doing, and to answer questions as we can, so that we, you know about as much as we do. We'll tell you when we don't know, but obviously things are changing. We had a speech last week that changed things a little more, so we'll be working through that too. But it's important that we get with you and let you know what's going on. Today we'll be briefing what we're currently doing this fiscal year, and also about the planning that we're doing and the content for next year. Lori will get into more of that as we get into this. You might ask, well, why this set of programs that we're planning for the coming year? The idea behind our budget request this year from the President is a shift from evolving existing systems into flight systems. Is stepping back and looking at what it takes in terms of technologies, research, and capabilities to go beyond where we've been before. And if you look back over the last probably 25 years, there have been numerous reports by various committees, commissions, study groups that have looked at what the future of human space flight should be, and generally they came up with a fairly consistent set of essential technologies, things that you just have to do in order to be able to go beyond low Earth orbit to these farther destinations, such as Lagrange points, the moon, to Mars and its moons. So if you look back at these studies that have been ongoing, that's what you find. And basically, the set of technologies that you see in our budget are encompassed by what it takes to go to Mars. Also in our budget is the idea to hand over transportation to and from low Earth orbit to commercial entities. And so there's the commercial COTS activity. Another area of emphasis is to invest in heavy lift technologies that will get us robust systems to go beyond low Earth orbit. So those are essentially the major ideas behind the budget that we have. It is a dynamic and evolving world that we live in, and we will be working with the administration and Congress to develop more detail on these plans that we'll work toward implementing in the next fiscal year. As the budget rolled out, we put in place fairly rapidly, probably within a week of the budget rollout, teams to go put forth more planning into what we'll be needing to do in terms of developing the programs and putting them in place to implement these programs that we're talking about. So we have teams for each of the major program areas that are in the budget request, including robotics program, flagship technology demonstrations, the Exploration Technology Development and Demonstration Program for commercial crew, for an augmentation of the Human Research Program, and I'm probably forgetting something, and the heavy lift technologies. So each of these program areas has teams. We also have a transition team, which is looking at what it takes to transition from the Constellation program to these new program areas. A lot of the work that's going into this is based on what we've learned and lessons learned in the transition work that we have had going on the last few years as shuttle retires and moving into Constellation. So there is a fairly significant amount of work there. So these are the teams we put in place. Just last week, we initiated a team called the Human Exploration Framework Team, which will be putting together design reference missions to going to these various destinations that I mentioned, to put more detail on what it takes to go there. These activities will actually lead us to a very good understanding of the priorities and the leverage that the various technology areas that we're pursuing will bring to these missions to these destinations. So that is an agency-wide team. It's being led by Steve Altimus from JSC and Dan Dumbacher from Marshall. But it's an agency-wide team. We will have a steering group here at headquarters from across the mission directorates and Office of Chief Technology and others in order to make sure that we get an agency-level look at what it takes to do the human exploration missions of the future. So that will be a very important activity, and actually will help bring together all of these various program areas and help us define in detail what it takes to prepare for future human exploration. With center assignments that have been made now in each of these program areas, we are developing points of contact and people that we'll work with at these specific centers, and these teams will be working with them in order to help us with the budget planning that we'll need to put in place for the next budget that we go out with. So we'll get more definition. We'll understand more about what centers will be doing in these new programs through that effort. If we talk a minute now about what we're doing this year, really I'd like to talk about what we've done over probably the last year period, and not just fiscal year 10. We have been living through a period of uncertainty during this entire time. We have had the presidential transition, we've had the Augustine Committee, and then we've had the changes that have resulted from all of this activity. So I want to say that I really appreciate the efforts of the headquarters team, the teams at the centers, all our NASA leadership in the exploration programs, for your resiliency and determination and dedication in supporting all the activities, both in terms of our ongoing programs and the planning that we're going forward with now. It's a lot of work, and I know everybody's been putting in a lot of effort. So that means a lot to all of us here in terms of making sure we get in a position for our best future. We have had, during that period of time, some really great successes. We had the launch of LRO, Lunar Reconnaissance Orbiter, and LCROSS. Lunar Reconnaissance Orbiter is continuing to bring us back great data on the moon. Saw some images this morning of where, in a lot of detail, how much sunlight different parts of the moon get. Some really great data coming from those missions. We also had the Orion PDR, preliminary design review last August. We had the DM1 test. We've had the very successful Ares 1X test flight in November last year. We've had 2 successful abort control motor tests. That was an area that we were having some difficulty with, but now I've had 2 successful tests, and that's gone very well. We've had successful parachute tests. We've had, from the standpoint of demonstrating technologies, we've had the desert rats and other analogs where we've tested out various technologies and demonstrated them. So that is adding to our understanding in those areas. We're flying racks and experiments on space station. Over this period, we've really accomplished a lot. And when I say we, I mean the whole team throughout all the centers here, and it's been terrific. We do have milestones coming up that will be important to us. The Pad Abort 1 test is coming up May 6th. The flight test readiness review is going this week out at Las Cruces near White Sands. We also have the preliminary design reviews for EVA, for mission ops, for ground ops that are coming throughout the rest of this fiscal year. There is, right now, near term, in early May, the first flight of the Falcon 9 from the COTS standpoint, so that's coming right up. When we were in Florida last week, we saw it sitting on the pad, so that was pretty exciting. So there's a lot coming up this year. Once again, I appreciate all the work that you all are doing as contributing to our successes. It is a time of change, and once again, I have confidence in our leadership and all the teams that support our leadership as we move forward. And obviously, with the announcements last week, we'll be updating our planning and guidance, and we'll be working through that and be getting back with you near term. And at this point, I'd like to turn the discussion over to Lori, who will talk about our plans for our new guidance and direction.
Thanks, Doug. And thanks to everybody who came and all of you out there at the centers. It's a great, it's a great thrill to be here with Doug, actually, and to be participating as part of the ESMD leadership team. I'm so thrilled to be here. As Doug said, I mean, I'm new to ESMD, but Doug and I have been working together for I'd say a little more than a decade now on various planning and other sorts of activities. So we know each other pretty well. Just a couple secs for people who probably don't know me. I came to NASA not quite 5 years ago now. Spent the last 4 years at Goddard, and just came down to headquarters when I got the call from Doug in December. And I thought, oh, this will be great. It probably won't be that crazy. Yeah, that was probably not that right, actually. But my background is I actually got started in this business as a summer intern down in Houston, right next to JSC at the Lunar and Planetary Institute. Really got turned on to space and exploration and space research. And so I've had a career as a space researcher. I study rocks from space. That's kind of was my thing when I was a laboratory scientist, and was a university professor and kind of did the traditional research route. And then was asked to participate in the Aldrich Commission when the Vision for Space Exploration first came out, and was very excited about the opportunities there that exploring space beyond Earth with humans afforded for the kinds of questions that I'm interested in answering about are we alone in the universe, and how did our solar system get here and evolve? Those kind of questions are really well answered with human explorers alongside robots. So I'm very excited to have a robust future human spaceflight program beyond Earth. So after the Aldrich Commission, we made all these recommendations and such, and I thought, well, I don't really just want to throw those over the fence and go back to my lab. I'd like to come to NASA and be a part of whatever that future is. So when the opportunity came along at Goddard to lead their Science and Exploration Directorate, and then I became a deputy center director there at Goddard was great. But this is a wonderful opportunity to come as we're changing direction a bit, but I think keeping the goal of our future human exploration program the same. And to me, that's a real key to all this, that the approach has changed and the philosophy has changed, but that the goal remains the same. And that goal is to explore deep space with humans, send them out there to stay, let's go. And so that's really what, in my mind, this program is about. I was really excited last week, really thrilled to get to go hear the president and hear firsthand his commitment to the future of NASA and future of human spaceflight. I hope that was good words to everybody out there to really hear his commitment to our future. It's definitely a different program, though. That approach and philosophy is definitely different. And I think that, in my mind, the main difference is about, instead of going straight to planetary surfaces like the moon and ultimately Mars, that we're going to do that with a more measured approach, looking at intermediate destinations along the way to Mars, places like asteroids. And you heard the president talk some last week about his announcement about missions to asteroids. That's very exciting to me. I actually have a little piece of an asteroid in my office. For any of you, when you come to headquarters, you can come by and hold a little piece of the meteorite that was once a piece of an asteroid. So very interesting objects from a scientific perspective. They're the building blocks of the solar system, but also, of course, they occasionally whack into us and do bad things. Someone at the Presidential Space Conference last week mentioned about, well, if we actually can send something to an asteroid and maybe even nudge it off course a bit, we'll once and for all prove we were smarter than the dinosaurs. I thought that was pretty good. So that, I guess you could call that one of the goals. But of course, it's not easy, right? I mean, the change is not easy. I know it's difficult as well. All of us have been through various challenging times in the space program. I personally was on live television, nationwide television, when Mars Polar Lander crashed into the surface of Mars. My friends watching out at JPL probably remember that day with me. I actually don't remember very much of it. It was kind of a blur. And of course, in the human spaceflight side of the program, we've been through some really difficult times as well. So, I can definitely tell you what that felt like for me. It was sort of like your heart gets ripped out. It's a real challenge. And I think big changes in programs feel sort of like that kind of loss. So rest assured that we understand how challenging this is. Doug could tell you lots of stories about going through various changes of program as well. But I guess our hope is that by sharing information with you, we can all do our jobs as space professionals and try and find things that we can like in this new program and get on board with making it happen, while honoring those things that we've done to get us here, while learning from those places that we've been. And so we're here to try and help make that happen. So how are we going to do that? How are we going to make it successful? Doug mentioned the teams that we have going, and those teams have representatives from many of the centers on them. So the centers are already providing lots of ideas and input to the various missions that we're thinking about in the robotic precursor program or in the flagship tech demo program, these various missions that are actually going to be very exciting in and of themselves, and also really important stepping stones to getting us to the future human spaceflight capability that we need to go to missions beyond the Earth-Moon system. So things like, for the robotic precursors, just to throw out a couple of things that we're thinking about. Missions that will land and send back great video from the surface of the moon, following up on the incredible discoveries of LRO and LCROSS. Even things that might be telerobotically operated from Earth or even from the space station, which, again, when we go out to some of these other objects like near-Earth asteroids and maybe even early missions to Mars, we may well telerobotically operate things on the surfaces of those objects rather than initially having that capability to send humans down. So these are going to be important precursor missions, not only to gain the knowledge that we need about these destinations, but also some of the capabilities we need to actually operate effectively at those destinations. So that's the moon. Asteroids, oh my gosh, we just don't know nearly enough about near-Earth objects. So sending missions out to scout locations for those objects is going to be very important. And then Mars, of course, there's much that we have to learn to send humans to Mars, whether it be about keeping humans safe there, understanding things like the toxicity of the dust, or scouting the best places to access resources on Mars, and also demonstrating the capabilities that we're going to need to land the scale of systems that we're going to need to eventually send humans to their surface. So there's a lot of opportunity there for for exploration robotic precursor missions focused on exploration goals to these objects. So that'll be exciting. And in addition, the flagship technology demos and the smaller exploration technology demo development and demonstration program capabilities. We'll be flying things in space using the space station as a great test bed for future exploration technologies, which one of the things I like about this proposed program is that it actually really firmly positions ISS along the path to future human spaceflight rather than just as sort of an aside, which sometimes it felt like to me in the previous program. So maybe that's not a good thing to say, but that's sort of how it felt to me. So using ISS for demonstrations of advanced robotics and maybe inflatable structures and various other technologies that are things that we absolutely need as we're going to move forward. We also need to learn how to store cryogenic fluids, fuels, and things for long-duration spaceflight, potentially fuel depots. We'll be demonstrating those kind of technologies with these programs as well. So I think you're going to see a flurry of activity with different missions going on. I think that it's going to be very critical that we continue to have the centers all work together on that activity. If we could have the next slide, please. I think it's the national meatball chart. Yes, there we go. Well, so there you guys all are. We did our initial assignment of program offices recently. And put those out there. So whether it's commercial crew at Kennedy or flagship demos at Johnson or the exploration technology development and demo program at Glenn, heavy lift propulsion research at Marshall. Those are great. All these pieces have to come together for us to have a future human spaceflight capability. And so just like we did in Constellation, we're really going to need the centers to continue to work together across these programs. And in fact, it feels more fragmented, and therefore the integration piece and the collaboration piece is going to be even more important. So just because we've assigned a program office to one center, doesn't mean that there's not going to be work across the centers in these programs. They're really going to require the capabilities from across NASA, so we're going to be really counting on everybody from the centers to help us get these programs even better formulated than they are to date and to start getting them implemented. Let me say a couple more words about that. The program offices, we've assigned the leads, but we're not standing up those program offices until the budget itself is enacted by Congress. But we're setting up some points of contact there so that we can do sort of our normal budget planning activities. So we will start to see even more activities at the centers as we get ready to move out here. And I hope that everybody out there is going to be ready to help contribute your ideas, your thoughts, because we'll also be doing things like workshops and calls for information. And as we get those center points of contact up formulating things, there's going to be a lot more opportunity for you all to get your ideas in. The truth is, we had to do some quick responses to the budget release, so we've had these teams working, these relatively small teams. We both feel very strongly that now it's time to open up the aperture a little bit and get some more voices heard, get some more people involved. Whether you're a civil servant or if you're a contractor watching as well, we're going to want your ideas. So be watching over the next few months as we come out with calls for ideas and workshops and other places where you can get involved, and we really need to hear from you. Just to wrap up, we hope you find this kind of communication useful. We are planning to do more of it, both in forums like this, but Doug or I are also hoping to do more visits around to many of the centers. We'll be setting those up over the coming weeks because we want to hear from you directly and in person about your ideas, but also we want to spend a little time honoring you for all the accomplishments that you've made as part of the Constellation program. And frankly, all across exploration. We sometimes don't do that enough around here. We need to spend some time and really make sure we all think about the great things that we've achieved and what we want to carry forward with us as we move into these new programs. And we know that it's a tumultuous time, it's a dramatic time of change, and so communication can only help. And we want to answer questions, and in fact, we're going to answer some now, I think, to turn it back to Ashley.
That's right. Thank you. Let's start with headquarters. Are there any questions here in the audience for Doug or Lori?
Hi. One question I have is we've talked a lot about heavy lift, but I haven't heard a lot about in-space propulsion. So do you think that that's something that's a near-term focus? Is that something that can be done in parallel, or do you think that's maybe after the heavy lift development?
We actually will be addressing in-space propulsion. That's an important aspect of this. Obviously, it's a high leverage area. It is dramatic in its leverage in terms of the amount of mass you put in orbit to go to a place like Mars. So it certainly is part of the equation here.
Are there any others? Okay, well, I don't see any, but I do actually have a couple that were sent in by email. So I'm going to read one of those for y'all. This is a little grab bag. I'm sure they enjoyed that. How will you ensure we will not lose all the results of the good work in Constellation? What work will be carried forward, and how will the efforts be closed out?
Well, we obviously we do have the transition effort, and the transition team is off working to identify the areas that have promise and really fit into the programs that we have going forward. Obviously, we will have the Orion in a crew return mode, but we are also developing technologies as a part of our current programs in Constellation as well as in our technology programs. We have automated rendezvous and docking as a part of it. We've developed thermal protection systems. We've got advanced avionics, life support. We're developing other crew systems and EVA capabilities. So there's undoubtedly a much longer list than I'm going to rattle off here. But certainly we've actually pushed pretty hard in some areas, and I think we will be carrying a lot of that forward.
Can I say one thing too? I mean, I think the other important piece of this is the Constellation PDR. So, I mean, these milestones, these gates, these reviews are places where the program comes together and really has a common set of knowledge, and that knowledge is captured. And so, in fact, it's one of the reasons we've been pushing so hard to push ahead with the program PDR and some of the project PDRs as well. So, again, it's not only an important milestone for the folks to know that they've reached and achieved and passed, but it's also a great time to capture knowledge in a consistent way.
And we did get through the technical part of the Constellation preliminary design review in the first week of March, and we're continuing actually to finish it through the work to lay out and define the schedule and cost aspects of that as we go forward this fiscal year.
Okay, well, without seeing any more hands in the audience here, I understand that we have some questions from Glenn. Would you please identify yourself as you ask? Thank you.
Good afternoon. This is Dr. Shantaram Pai talking from NASA Glenn Research Center in Cleveland, Ohio. I have one clarification question and two technical questions. I watched from 11 p.m. to 1:30 a.m. all the presentations starting from President Obama all the way to Dr. Augustine and so on. And there was one issue that I was puzzled that Dr. Augustine mentioned. There is some technology problem on Ares 1. I had a little bit of role working on Ares 1X. Secondly, do you have any plans to cooperate with other countries, just like India has identified water on the other side of the pole of the moon? And third, from my personal point of view, is there any research going to be taken place on the coupling technology of bone mass reduction and the radiation effect on the astronauts for a longer duration of stay in Mars and so on? And lastly, this communication system that you have developed, I deeply appreciate, and that shows the lot of emphasis on transparency and communication. Thank you.
Thanks.
All right.
How long do we have?
Take a few more minutes.
Good questions. No, all good questions.
Yes.
Brave for going first.
I believe the first one had to do with mention of technology or
Ares 1.
Ares 1 technical issues. We have had Ares 1 technical issues, as you do in any development program. We've been working through those. Actually, at the PDR in March, we stepped through all of those. And for instance, the thrust oscillation, which has caught a lot of attention over the last year, has a design to mitigate it, and so that one has been worked through. This is not atypical of a development program to have design problems that you work through. That's why we have so many good engineers working on it. So I think those are being worked. The program is very diligent, and the projects are very diligent in working them off.
International.
In the international arena. One thing I didn't mention was that we do have an international team.
Right.
And
Kathy.
and yeah,
Kathy
here,
Lorini's here.
who leads it. We certainly believe that this future that we see in exploration will definitely be international by nature, and certainly we've had efforts underway to develop the communication with at this point 13 other space agencies around the world, to be expanded with new partners as we go forward. So I think certainly international involvement and direct participation is important and something that we want to do.
Can I add something to that one?
Absolutely.
Yeah, I mean, I think there's both the long-term piece of international cooperation, which I think all of us in our heads know that, you know, we're not going to Mars alone, right? We're going to go as a planet. But then there's a lot of near-term opportunities I can see in this program for international cooperation as well, both on the robotic precursor missions. A lot of these nations are very interested in robotic precursors, on, you know, more ISS utilization, which this budget also calls for. And again, many of these nations are highly committed to ISS. And third, on the tech demos, which is always sort of the interesting one, right, because of the ITAR concerns and such. And I think that we've got a really interesting conversation coming up about, you know, internationals on the critical path and what that could mean. I think right now we need to look at where are people's interests in developing important capabilities. And that wouldn't mean that we would necessarily stop developing them. We might be co-investing for a while, and at some point later we would down select and decide which direction to go. I think this program is very interested in getting a lot of international conversation going very early on, which is why we're thrilled to have Kathy leading up one of the teams for us to try to lay out that plan. So there's a lot of opportunities. I think it'll be very interesting.
That leads us to number 3.
Number 3 was about radiation, long-term radiation research for Mars, or something like that.
Right. And,
oh, yeah.
And certainly radiation, understanding the effects of radiation is important. It's maybe one of the tall poles in exploration beyond low Earth orbit. As you get out beyond the Earth's magnetic field, you're subject more and more to galactic cosmic radiation, which is always there. We don't understand the effects of it on human cells that well, and it's something that we need to learn about. And we do have experimentation planned in the future. We have a facility at Brookhaven National Lab that can do that research, both in understanding the effects as well as shielding. We'll learn about bone mass reduction and other zero-G effects on space station, which is ongoing. We actually have work ongoing there that will be continuing through our enhanced human research program.
Yeah, there's a 40% increase in the human research program in this proposed budget, so it's a significant augmentation to really continue that work and expand it.
Okay, so I understand that we have another question from Glenn. So if you would please identify yourself.
Jeff Motor at NASA Glenn. Before doing human missions to the surface of Mars, our long-term goal, I assume we want to develop both expertise in long-duration spaceflight and long-duration surface operations, including the descent and ascent. And Augustine's committee's flexible path approach, suggested starting with the deep space missions, since you could do these before developing a lander and the surface hardware. And of course, the new exploration plan, starts with the deep space missions. But I've heard very little about the surface operation part. And doesn't the Earth-Moon still offer the most logical place to build up our expertise in long-duration surface operations? And if yes, why aren't we making it very clear that human missions to the lunar surface would occur before attempting human missions to the surface of Mars?
I don't think that level of definition is in the guidance at this point. I certainly all of those aspects of the knowledge for these missions is extremely important. Landing technology, things that we do in surface operations, is tremendously important. Right now, we are, in terms of Earth-based analogs, we are doing that kind of work to understand the technologies needed. On the robotic missions that we have planned, we're going to be flying landers that employ precision landing hazard avoidance technology that's important. We just found out today we've been through a full range of testing on RL-10s in terms of throttling 18 to 1 That's important for landing technology. That's in the existing technology program that we have. We'll be furthering all of those. Certainly the moon provides that capability, and we'll be laying out those plans through the HEF team in terms of what things we need to do when in order to prepare. Mars is a difficult place to go, and we don't know all there is to know. We need to understand, as Lori mentioned earlier, we need to understand the environment at Mars better than we do now in terms of potential toxicity of the soil. We need to understand entry, descent, and landing technology with big vehicles that it takes to fly people there at that level of gravity, which is about 0.38 that of Earth. So landing there is not easy either. So all of those things are important. We'll be laying out that planning, what it takes, because we will do the work necessary to be safe when we fly people to these destinations.
Yeah, I mean, I totally agree with that, and I think the exact right answer is, we're not exactly sure yet of what the sequence will be before lunar missions. You can certainly imagine, or before Mars missions, excuse me. You can certainly imagine lunar surface missions in there once the surface capability is developed. I think the key is in the near term that we're going to focus not as much on that surface capability, just because of there's only so many dollars, and so the early deep space development does allow you to focus on those areas. But again, there's a lot we can do on Earth, and there's some things we can do on ISS to prepare for Mars missions as well. So we'll be thinking about all those different ways of preparing for Mars.
Okay, great. Well, I understand that we have a question from Marshall. Again, I'd remind you to identify yourself, and we'll take that question now.
Thank you. This is Dick Holmes from Marshall, and I hope what I'm saying is not a day late and a dollar short, but there's a consensus that the space shuttle is too expensive to maintain from flight to flight with all the maintenance and everything. But we've been working here for over 10 years making it better, and we've been working up the TRL, which we got our money cut off when Bush said we were going to the moon and Mars. But we've got an engine here with 220 hot fire tests on it in pristine condition. The same test for the space shuttle, they get blanching and cooling channel cracks in less than 30 of these hot fire tests. Every time the space shuttle flies, you got to take the engine apart and take a ball peen hammer and pound the cooling channel cracks back together. You've got to take and polish the combustion chamber liner to get the blanching off, or it'll burn up the next time. You don't have to do that with our engine, so you're going to save some money there. We've got other things that we've done to save money, and all I'm saying is am I too late in trying to pull together the cost that it takes in everybody's mind to maintain the shuttle and see how much of those costs that we can cut out? Especially when you compare it to the Constellation program, which I'm fully endorsed and in favor of, but that thing was underfunded to start with, and there wasn't enough money to do the testing that was required to get to the moon. There wasn't enough time to do the testing. So if you're comparing cost of the shuttle against the Eris-1, you're comparing it against a low budget, which is not realistic. So all I'm saying is, am I wasting my time trying to pull together this information to see how much of the cost that we can save? And is the shuttle really viable for taking people back and forth to the space station in the next 10 years?
Well, the guidance we have at this point is that the shuttle will be retired. It's definitely not too late to understand how we can save money in our programs. We always have the challenge to try to fit as much as we can into our existing budgets to do as NASA will try to do as much as it can and progress as far as it can in its programs. So I think learning about where we've been and our experience is extremely important. I certainly have enjoyed working on the shuttle a good part of my career. I spent a lot of my career working on a space shuttle. It's a marvel in my view of engineering through its lifetime. it's at the point of being retired at this point. We'll learn from it. We need to. As we move forward in the heavy lift technology program, we're going to be going out with requests for information. We're going to be going out with study contracts to really understand the best approaches to heavy lift as we need to build the vehicles to go beyond low Earth orbit.
Yeah, and I think that's the place where your ideas can
Right.
come to play. I mean, if you've got great ideas for how to keep engine developments and tests and use low cost, that's exactly what we're looking for in the new heavy lift research and propulsion program. So I encourage you to, and it's at your center, so I encourage you to get your ideas in there.
I think we have one more question from Marshall. Please identify yourself.
Holmes here again. Just as a follow-up, in case this sparks anybody's interest and they do want to look into this more, and they'll start saying, well, we've shut down this at Michoud, we've already ripped out the electrodeposition baths at Canoga Park. All I got to say is it takes them a year to close out the cooling channels on the Space Shuttle main engine at Canoga Park. We can do it in 2 weeks.
Sounds like some good ideas
Thank
there.
you.
Yeah, that's great. Okay, I believe we have a question from Johnson Space Center now. Please identify yourself.
Good afternoon. This is Dr. Robert Howard at Johnson Space Center. I have a quick question. Following some of the flagship discussions, I've heard very little talk of humans in space other than ISS, at least until we go to an asteroid or to Mars. What roles, if any, do you see for a NASA human presence in space beyond LEO in the execution of these flagship programs, particularly in the 2015 to 2025 timeframe?
You want to do that one?
You want to take the first hour? Yeah. It's the boss, right?
Well, obviously, we are going to be flying people to the space station. We're going to be learning through development of technology there and demonstration. We are, the planning is to have people go beyond low Earth orbit, and the President talked about going in mid-2020s. Or
Actually talked about test flights in the early 2020s.
right, test flights and then missions to asteroids. So those are what we're working with now. Actually, as we pull together the time it takes to develop those vehicles, we will be laying out roadmaps on what it takes for development. We'll be looking at where the logical points are for the flying of people and the best use of astronauts in space.
Yeah, I agree with that. I mean, I think that the HEFT, the Human Exploration Framework Team, that's the HEFT, if you've been hearing about the HEFT, and if you hate the acronym, you can blame me. So that's part of their task, is to kind of put these pieces together and see where it makes the most sense for those future human missions. Of course, we have to develop those future human systems for those humans to fly on. And I think the President's announcement last week that we would be keeping an initial Orion build as a crew rescue vehicle from station, but again, hopefully positioning for the future human spaceflight vehicle for deep space that we're going to need. To me, that was very exciting, that we're going to keep that sort of going at that level in the budget now. So I think there's that as a great opportunity. I also think humans will be involved in flagship missions, because humans will be at station and flagship missions will be at station. Some of them will be at station. So humans will be very critical to our future success there as well. But again, I think following on the President's announcement last week, you're looking at early 2020s for the first crewed test flights, and then the mid-2020s for that hopeful asteroid mission.
Okay, I understand that we have a question from JPL. Please identify yourself.
Yes, my name is Ernest Robinson. I'm a retired aerospace nuclear engineer with experience years ago in the NERVA program. I'd like to make a comment about nuclear propulsion and then to ask a question. I think it's pretty well accepted that you can't get to Mars with a heavy payload without the use of the nuclear rocket. Given that, the effect of incorporating the nuclear rocket into a Mars mission has several synergistic benefits, one of which is the reduction in the amount of cargo that you have to prepare in Earth orbit for the departure vehicle. That reduction is great enough that you can invoke the Shuttle C, as mentioned in the Augustine report, capable of 100 metric tons to low Earth orbit. The shuttle then becomes the vehicle that provides the logistics for low Earth orbit, and does so with technology and operations and risk levels that are comparable to what we have in the normal shuttle operations, and not the added cost, development, qualification, and risk of the brand new Ares 5 and Ares 1. With that in mind, the question is, can we anticipate that within the emerging space program, there will be the flight qualification of the nuclear rocket?
Well, I think I mentioned early on in the briefing that I think maybe the first question, certainly in-space propulsion and the kind of efficiencies and ISP, specific impulse that you get from advanced in-space engines like nuclear thermal rocket engines, like the nuclear electric propulsion for cargo, for instance. It really, I think, in my mind, is essential that we go that route. If you look at the efficiencies that you get in terms of, as you said, the amount of mass delivered to low Earth orbit to do a Mars mission, this type of technology and propulsion reduces mass in orbit by a factor of about 2, which is obviously very significant. And in terms of the amount of fuel that you have to put in orbit just to put through the engine. So it's extremely important that we put resources in development of those technologies. It is very high leverage. It's been looked at in numerous reports for Mars. If you go with basic chemical engines, even the most efficient chemical in-space engines that we can do, which is hydrogen and oxygen currently, there are some opportunities in going to Mars that it just almost doesn't pay to go. There is a 15-year cycle that you go through in terms of opportunities in going to Mars, and some are easier than others in terms of the amount of fuel it takes to get there. These propulsion technologies actually flatten that out quite a bit, and in my mind, if you're going to go on any kind of regular basis to a place like Mars, you really need to develop them. The NERVA program actually demonstrated nuclear thermal propulsion. If I remember right, it was canceled in 1972. But it demonstrated an actual pretty high thrust engine at that point. So the technology is possible, and certainly it'll be important to us, I think.